Our objective today will be to graph cubic and cube functions and determine the domain, range, intercepts, symmetries, asymptotic behavior, and max and min on a given interval. To do that, I'm going to instruct you with this video. I want you to take notes, pause when you need to copy anything down, and do all of the work in your group or individually to complete the assignment. Start by splitting your paper in half. On the left side, we're going to work with the cubic function, f of x equals x cubed. On the right, we are going to work with the cube root function, f of x equals the cube root of x. How a cubic function works is we take a number times itself 3 times to get our solution. So if I had that x equaled 2, we would write this out as 2 times 2 times 2 to find our solution. If we plug this into our calculators, we can get that our solution would be 8. On the other side, instead of having a number times itself 3 times to get our solution, we have to ask ourselves what number times itself 3 times would get this solution. So instead of saying that x equals 2, I'm going to say over here that x equals 8. And now we have to figure out what number times itself 3 times will give us 8. And if we type it in the calculator, we actually have a button on the calculator that will do the work for us. We can go into math and go down to 3 root x. This is the cubed root of whatever we type in. So I'm going to hit enter on that, and you can follow along with what buttons I push over here. So I'm now going to type in 8, and that'll give me that my answer is 2. So coming back here, I have that the cubed root of 8 equals 2. I drew a quick sketch of both of the graphs. This is the graph of a cubic function, and this is the graph of a cube root function. Notice that we have our starting point right here on the cubic function at 0, 0. And on the cube root function, we also have our starting point at 0, 0. So for the cubic function, our starting point is 0, 0. Our domain is going to be all real numbers, and our range will also be all real numbers. Let's look at the graph and see why that is. This function goes up and to the right to infinity, and it goes down and to the left to infinity as well. Because the graph never stops going up and right or down and left, the graph will go forever, which means we have a domain of all real numbers and a range of all real numbers. For the cube root function, we also had our starting point at 0, 0. We again will have a domain and a range both of all real numbers. And we can look at the graph and see why that is. This graph goes to the right to infinity, and it's also still going up slightly to infinity. The graph also goes to the left to infinity and also slightly down, but it still goes to infinity. So again, we have a domain and range of all real numbers for both the cubic function and the cube root function. And again, both of our graphs have a starting point at 0, 0. I also mentioned at the beginning of the video that we had to talk about any symmetry that the graph has. And it's not obvious right away any lines of symmetry. It doesn't have a vertical line of symmetry. It doesn't have a horizontal line of symmetry. What it actually has, though, is a rotational symmetry at the starting point. And what that means is if we take half of the graph and rotate it 180 degrees, we can see that the two halves of the graph would be the same. So if we rotate this graph 180 degrees, we have rotational symmetry, and that rotational symmetry again is at the same spot as our starting point. For the parent function, that point is 0, 0. Just like when we had a quadratic function and a square root function that were inverses of each other, these two graphs also are inverses of each other. And what that means is if we take a line and we take the line of y equals x that goes right through here, and we were to flip the graph over this line, we would turn this function, this graph, into this graph. These two functions are inverses of each other, just like they were inverses when we had the quadratic function and the square root function. Now we're going to fill in a table of values for both the cubic function and the cube root function. And we're going to notice a little bit of a pattern. I'm going to start off with just the point 0, 0 on both of these functions, which is my starting point. For my table, I'm going to start at 0, 0, and I'm going to put 2 points to the left, which would be x equals -1 and x equals -2, and then 2 points to the right, which will be x equals 1 and x equals 2. Now, because these two graphs and equations are inverses of each other, that means I can switch the x and y values of my cubic function and change them into my cube root function. So instead of having my x values of -2, -1, 1, and 2, instead my y values will be -2, -1, 1, and 2. Now I'm going to take my x values and I'm going to plug them in and find my y values for my cubic function. So using my calculator, my values I need to plug in are -2, -1, 1, and 2. We already know that I go through the point 0, 0. So first I'm going to plug in my -2. And you cannot forget your parentheses. If you forget the parentheses, the math will be done a little incorrectly. I'm going to plug in my -2, and I'm going to go to math, go down to the 3, and that's going to give me -2 to the third power, which is -2 cubed, and that tells me that it's -8. Then I'm going to just plug in all of my other numbers. Again, don't forget the parentheses. I'll plug in my other numbers, go to math, go down to 3 again, and that's going to tell me that I have an answer of 1. And I'm going to continue that for all of my numbers until I fill in my entire table. So that means I now have 1 to the third power, which will give me 1, and 2 also to the third power, which will now give me 8. And now I have all of my values for my table. So I have my table of values filled in for my cubic function, but I still need to fill in my table of values for my cube root function. Well, we know that these two functions are inverses of each other. So my table of values here is going to actually just be a mirror copy of all of these values. Now, the pattern that we have for this is if we start at 0, 0, if we go to the right 1, we go up 1. If we go to the right 2, we go up 8. If we go to the right 3, we'll actually go up 27. And the same thing happens if we go to the left. If we go left 1, we go down 1. If we go left 2, we go down 8. And if we go left 3, we go down 27. And we can see that on my table of values. If I went left 1, which means to go to a negative, I went down 1. If I went left 2, I went down 8. If I went right 1, I went up 1. And if I went right 2, I went up 8. The same thing happens on this graph, but the inverse happens. Instead of going right 1 and up 1, right 2 and up 8, I'm going to go up 1 and right 1, and I'll be at 1. I'll go up 2 and go right 8. I'll go down 1 and go left 1. I'll go down 2 and I'll go left 8. So my table of values here will be -8, -2, -1, 1, 0, 0, 1, 1, and 8, 2. Right here I've given two graphs, one of a cubic function and one of a cube root function. And I've told you the starting point for each of the two. The cubic function starts at 2, 3, and the cube root starts at -3, -4. We're going to fill in the cubic function table first. And to fill in this table, we need some more x values to be able to fill it in. Remember on the previous page, we started off with 0, 0. We went left 1 and left 2, and we went right 1 and right 2. So for my table of values for my x cubed function, I'm going to fill in 1 and 0. I went left once, I went left twice. I'm also going to fill in a 3 and a 4. And that's because I went right once and then right twice. I now need to get some values for my cube root function. And if we look at the previous graph, we notice that over here, when we go down 1 and down 2 on our f of x values, and up 1 and up 2 on our f of x values. So I'm going to do the same for my f of x values on this table, and I'm going to fill it in with -5 and -6. I went down once from -4, I went down twice from -4. Then I'm going to go up once and up twice. Now to fill in the rest of the table, I can use that same trick that I just used on this page that showed us that when I went left once, I went down once. When I went left twice, I went down 8. The same thing will happen here. When I go left once, I'm going to go down once from this value. So 1 less than 3 is going to give me 2. When I go left twice, which gets me to 0, I'm going to go down 8. So 8 less than 3 is going to give me -5. The same thing happens the other direction. When I go up once, when I go right once, from 2 to 3, I'm going to go up once, which will put me at 4. When I go right twice, I'm going to go up 8. 8 more than 3 is 11. The same thing will happen over here. When I go down once, I go left once. So 1 to the left of -3 will get me to -4. When I go down twice, I'm going to go left 8. 8 left from -3 gets me all the way over here to -11. When I'm going up once from -4, I'm going to go right once. So 1 to the right of -3 gets me over here to -2. And then when I'm going up twice from -4, that's going to take me all the way over here, right 8 more points to the right of -3, which will get me to 5. What I now want you to do is work on these examples. For each of the given starting points, find the f of x values asked for and the domain and range of the graph. You can work with a partner.